All right, the whale eats several tons of kelp every day, and this particular whale kept careful track of her daily kelp intake every day for a bunch of years and created a PDF of their consumption. So we want to find the percentage of days where the whale ate between 7 and 8 tons of kelp. So that means I want to find the area under the PDF between 7 and 8. So I'm just going to go up to my curve here. I need to find this area. So I'm going to break it into two pieces. This rectangle has a base of 1 and a height of 0.12. And then my triangle has a base of 1 and a height of 0.12 to 0.18 is 0.06. So this is 0.12 plus 0.03, which is 0.15, or 15%. And then part B, the probability that this whale will eat between 7 and 8 tons of kelp on any given day. Well, if on 15% of all days the whale eats between 7 and 8 tons of kelp, then the probability that any random day it eats between 7 and 8 tons of kelp is 15%. It's really the same question as the previous. A quality control engineer studies how long light bulbs from a given factory work before failing, and we have a probability density function for the number of months from manufacture before a light bulb fails is this formula. That's the PDF for some constant C. So if 20% of the light bulbs, if 20% of the light bulbs fail in the first month, find the value of C. So 20% failing in the first month, that's the area under the PDF. So the area under my PDF curve is 0.2, and they're failing in the first month, so between month 0 and month 1. And I want to solve this integral for C, solve this equation for C. So I need an antiderivative of CE to the negative CT. So that is going to be, well, an antiderivative for e to the negative CT would be e to the negative CT over negative C. And I still have this C in front. So my C's cancel. And I end up with negative e to the negative CT. If that isn't obvious to you, then you should do a U-substitution where you let u be negative CT. Calculate du dt is negative C and u sub, right? You will end up with an antiderivative of negative e to the negative CT. And we want to evaluate that from 0 to 1. So when I plug in a 1, I get negative e to the negative C. And when I plug in a 0, I get negative e to the 0. So this is negative e to the negative C plus 1, and I need to set that equal to 0.2. So when I solve, I get e to the negative C equals 0.8. Take the ln of both sides so that negative C equals the ln of 0.8. So C is negative ln 0.8. Using the unrounded value of C from the part A, what is the probability of a transistor light bulb failing at some point during the first year? So the probability, or the percentage that fail in the first year, is the integral from 0 to 12 of CE to the negative CT dt. And now I know what C is. C is negative ln of 0.8. So I want to integrate from 0 to 12, negative ln of 0.8 times e to the negative CT, which means ln of 0.8 to the t. dt. So I'm just going to punch this into a calculator and you get approximately 0.931, or 93.1% probability that the light bulb will fail within a year. Okay, find the median of a list of numbers. So that is the number with half the numbers below it and half the numbers above it. So it's helpful to write these in numerical order. 1, 2, 3, 4, 8. The number with half the numbers below and half the numbers above is 3. I want to find the median number of tons of kelp eaten per day for the whale. Okay, what is his median number of tons of kelp eaten each day? So that means I'm trying to find the median of infinitely many numbers. So we are looking for a value for which half of the area under the curve lies to the left and half lies to the right. Okay, so I'm just going to draw a random spot here. I'm going to pick right here at like 3. So if I draw the area under the curve at 3 and shade it, I've got about maybe 10% of the total area under the curve here, and then 90% of the area under the curve is this, right? So that does not look like the two areas are approximately equal, 0.5 and 0.5. So what I want to do is sweep a vertical line through here between 2 and 8. I'm just going to eyeball it. I'm going to stop where it looks like I have approximately half the area to the left and half the area to the right. So I'm going to say it happens approximately here. So if I draw this, I've got some area in blue here, and then I have some area to the right in pink. And this is just an eyeball guesstimate that the blue area and the pink area are about equal, about 0.5. So what I'm looking for is that I want this blue area, the area between 2 and this unknown value, let's call it t. I want the area between 2 and t to be a half, because the total area under any PDF curve is 1. So I want the blue area to be a half and the pink area to be a half. So the way you represent the blue area is the integral from 2 to t. And the line that I'm under here has a formula 0.04x. And I want that area to be 0.5. So I have to figure out what value of t will make that true. So antiderivative of 0.04x is 0.02x squared, evaluated from 2 to t. I need that to be 0.5. So 0.02 t squared minus 0.02 times 4, which is 0.08. I need that to equal 0.5. So that means that t squared is 29. So t is approximately 5.4. So 5.4 is the median number of kelps, tons of kelp that the whale eats per day. So the conclusion is that to calculate the median, we take an integral from -infinity to t of the PDF function dx, and we set it equal to 0.5. You are free to use this formula on a quiz or a test without doing any slicing. We did already use this formula up here. The reason we started at 2 and not -infinity is because there was no area to the left of 2. So we essentially used this formula. Okay, find the mean for a list of numbers. So mean is just another word for average. So we add these all up. Plus, 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 and you divide by the number of numbers, 5, and we get 3.6. So the mean for a list of numbers is where you add them all up and then divide by the number of numbers. So we want to find the mean age of all people in the United States. So to find the mean age of all people in the US, we would calculate the sum of the ages of all the people in the US and divide by the total number of people in the US. But adding the ages of all people in the US would be ridiculous. That's too many people. So instead, we're going to approximate the sum with an integral. We're going to cut the horizontal age axis into tiny pieces so that all people on each tiny interval have nearly identical ages. And n, capital N, is going to be the total number of people in the US. This is a constant. This is just some number, somewhere around 300 million. So we want to use the diagram to fill in the blank lines. The diagram is telling me that the shaded area, that's the area under my PDF function, is the percent of the population with age between t and t plus delta t. So to find that shaded area, I would multiply the height of the rectangle, p of t, times the width of the rectangle, delta t. So this is p of t, delta t. And then the number of people with the age between t and t plus delta t. Well, I know the percentage of people with that age. To find the number of people, take the percentage who have that age, and then multiply times the total number of people, n, in the United States. Then I want to sum the ages of people between t and t plus delta t. So that is, let's say I want to count up all the people who are age 21. I would do 21 plus 21 plus 21 plus 21 and keep adding 21s for the total number of people. Okay. So I know the number of people that have a constant age. The number of people is p of t delta t times n. And then that's the number of people who have age t. So I want to multiply by their age. And that will be the sum of all their ages. Now we use a Riemann sum to add up the ages of all people. So I'm going to sum t sub I, p of t sub I times n delta t. I goes from 1 to n, and take the limit as little n goes to infinity. Little n is the number of rectangles, not the capital N number of people in the United States. All right, so to convert our Riemann sum to an integral, integrate. I'm going to pull the n out because it's a constant. And then I have t times p of t dt. And I'm integrating from 0 to 100. And then finally, we divide that integral by n because I have now added up the number of ages, the number of numbers, and now I have to divide. I've added up all the numbers, divide by the number of numbers, n. So if I divide by n, it just cancels with the n out in front, and this becomes the integral from 0 to 100 of t times p of t dt. So the conclusion, if you want to find the mean, you calculate an integral from negative infinity to infinity of x times p of x dx. And again, you're free to use this on a quiz or a test without doing any slicing. Just treat it like a magic formula. All right, last problem, the mean number of tons of kelp eaten per day from our earlier example. So I'm just going to use this formula that I just scrolled up past. So the mean is the integral from negative infinity to infinity of x times p of x dx. Okay, so the integral is from negative infinity to infinity, but my function only goes from 2 to 8. Before 2, the function is 0, and after 8, the function is 0. So there's no area underneath it there. And then I have two different formulas, one from 2 to 6 and another from 6 to 8. So I am going to break this integral into the integral from negative infinity to 2 x p of x dx plus the integral from 2 to 6 x p of x dx plus the integral from 6 to 8 x p of x dx plus the integral from 8 to infinity x p of x dx. Now these first and last are just 0. The area under the curve is 0 because the function value is 0. And then the integral from 2 to 6, that's going to be the integral from 2 to 6 of x times p of x. Its formula is 0.04x dx. And then the integral from 6 to 8 of x times p of x. Its formula from 6 to 8 is negative 0.06 x plus 0.6 dx. And then these are fairly straightforward to do by hand, or you can put them in a calculator. You get 2.7733 plus 2.48, and that's approximately 5.253, or it's exactly 5.253 tons of kelp. Is the average number of kelp, average tons of kelp per day that the whale consumes.